So, let me see. Tic, tac, toe. So basically, we want an object, right? They tell us to define an object called tic, tac, toe. And it's going to have a board. So the question asks you to go through the test specs and see what it wanted from you, right? So, if you read, you can see that it wants a board property, and its value needs to be an array. And it needs to be an empty tic-tac-toe board. Now, if you think about tic-tac-toe, it's pretty much a grid, right? And how do we represent grids in computer science? Two-dimensional arrays. And by reading the test specs, you know an initial board will have all of its values be null. Literally the null value, okay? So, we can do this. And there we have our initial empty board. Okay. Have I lost anybody yet? We made an object called tic-tac-toe. We put a board property in it. Board property. The key is board, a string board. And the value is an array of more arrays, 3 arrays, with 3 things in each of them, which are null. Okay? So, now we need the move function. Okay? So if I'm playing with one of you guys, we each have to call this function move to put one of our places inside this board. So I'm going to do tic-tac-toe.move equals a function. I can do this. Is this confusing to anybody? I'm saying tic-tac-toe.move. That means I'm accessing a property on tic-tac-toe that's called move. I'm looking for a key that's called move. Whatever it is, if it exists or not, it is now going to be this function. Yeah.
Is that the flat arrow way to
Yes. So this is the same thing. Same thing. You guys learned about the this keyword, right? On Thursday? A little bit? If you plan on using the this keyword, don't use fat arrows, okay? For now. Because the fat arrow and the this keyword, the fat arrow does some... I'm not going to go into it because I don't want to confuse anybody, but the fat arrow alters the reference of this, okay? So, I'm going to stick to writing functions like this for now. But I'm still going to define the move function outside of its parent, right? Because I could put it in here, right? But in this case, I actually could use this keyword. But I don't want to get into that right now, okay? So, the move function. So, the rules of tic-tac-toe. If I put an X here, can you put an O there? No. So the only way that we can make a move is if and only if the current space is null. Does that make sense? So, that is the first thing we're going to check, because that is an absolute no-no. We cannot do that, right? So, we will say if this dot board at it takes a player, it takes a row number, and it takes a column number. Okay? If this dot board at row num at column, and that's all we have to check. Oh, bang. This is all we have to check, because this dot board at row num at column, okay? This is going to give us one value inside one of these multi-dimensional arrays. If that value is null, the if statement won't be true. But that's what we're looking for. We're looking for a null value. So we put a bang in front of it, and that will make null truthy. It will coerce null into the opposite of its truthiness. Okay? The other options that could be inside this board is a string x and o. And a bang x or o will be false, so the if statement won't run. Okay? So we will say this dot board at row num at column num is now going to be player. It's going to be X or O. Does that make sense? And then I think we just return the board. So, if I console.log tic-tac-toe.move X 1, 2, we get null, 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 X, null, null, right? Because 1, row 1, 2, the second, not the second, it's the third, by index. 0, 1, 2, the third element, the second index of the column. Okay? Have I lost anybody? Does anyone have any questions about the move function? Yeah.
The tic-tac-toe move, why isn't that within the object? If you scroll down, why isn't that within the object?
Because my personal preference, I chose to define that function outside of the object. However, I just want to hammer something into you. If you guys are using fat arrows, this won't work. Okay. Okay. I don't want to really get into why it won't, but just be careful. When you use this, just don't use the fat arrow way. Okay. Because basically, what it does, the fat arrow, well, where you define the function, it passes down its reference to this. So the this and this is actually referring to the global window object. But don't worry about that, okay? Okay? Is anyone confused as to why this is working? Does everyone understand why I can just do this outside of the actual object definition? Okay. So now, we have the clear function. That one I will put in here, because why not? So we have the clear, and that will be equal to, I will use a fat arrow, that will be equal to this. So here, I can just do this dot board equals that. Then I can return this dot board. So if I do tic-tac-toe, wait, hold on. So if I do console.log tic-tac-toe, pass in an O, make it an oh shit. I'll make it an O this time. 1, 1. Oh. Dot move, right? We get the O there. But then if I do console.log tic-tac-toe.clear, invoke it, as you can see, we have cleared the board. It is no longer has the O there. Okay. The clear function, I thought, was really easy. But it's okay if you got tripped up by the way they asked you to do it. Does anyone not understand how what I'm doing... Oh, shit. Let me fix how this looks. Okay. Does anyone not understand why this is clearing the board? The function is being defined inside of the object. So, the this keyword, we can use a fat arrow, because the this keyword is inside of this function, okay? We are saying this dot board. We are literally talking about this board, this exact board. We are now reassigning it to what it was before, just hard-coded an empty board. We do not have to loop through this dot board and change every value to null. We can just do that, okay? And then we just return it at the end. Any questions? Yeah.
Again, so can you go over why the clear has a this, but it also has a fat arrow?
Because I don't want to get too deep into this because it's outside of the specs of this course, but it's because of where the function is defined. The clear function is defined inside of tic-tac-toe, whereas the move function is defined inside of the global scope, inside the window. So the fat arrow changes what this actually is. Okay? You can look that up on your own, or we can talk about it later after class. Any other questions before I do the taco cat problem? You guys sure? All right. Taco cat, taco cat, taco cat. So this one had like a thing, right? Like I have to copy and paste something. Hold on. Yeah, so here they give you this thing, right? This object called Taco Cat Inc., which is a company, okay? And it's an object of more objects. There's more objects, but then there's this cache thing down there, which was kind of annoying for some of you probably, right? Maybe everyone. The cache thing is annoying. So, how do we do, what do we have to do exactly? Okay, so, I will say, now, we will define functions outside of TacoCat, right? Because that object was given to us, it already exists, so let's not like put things inside of it. Let's just do it like this, right? TacoCat Inc. dot current inventory, and that's going to be equal to a function. Whoops. And that function will take no parameters. So the point of this is to see how much, not like how many things are in the current inventory, but how much the current inventory is worth, okay? So you might be thinking, let's loop through TacoCat, go into these objects, then do this, multiply these things, whatever, and we'll get the answer. But the cache thing is actually a problem, right? Because we don't want, if we try to do the logic of going into this object, you can't go into this object because it's not an object. This is a number. Cache's value is the integer 0, okay? So, how do we do this? Well, the first thing we want to do is we want to say let total equals 0, because that's what we're doing, right? We're multiplying things together and putting it to a total of how much everything is worth, right? The answer will be this number, right? Does everyone understand that? Okay. So now we could say for let's category in this. What is this? What? It is TacoCat, because I'm using the function keyword and it is referring to this, okay? So this is literally TacoCat Inc., okay? So for let category in this. First, so what is category going to be? The key, right? Each time it will be gourmet shell, gourmet fish filling, gourmet veggie, gourmet seasoning, and cache. If category is not, well, is equal to cache, no, is not equal to cache, then we can do a bunch of stuff. Right? If it's not equal to cash, we can go into those objects and find out how many of these things there are and how much they're worth, multiply them, and add them to the total property. But if it is cash, this if statement will not be fulfilled, right? This conditional won't be met. This condition won't be met. So inside the if block, nothing will run. Okay? So here, we can say, let's items equal this at category. So now, items, so like in the first iteration of the loop, let's say we're at gourmet shell. So items will be, will be this object, an object of two key value pairs, hard treat shell and soft treat shell, with values of another object with two things. So we can say these are items, right? 1, 2, 2 items, plural. So now, since this is an actual object, we need to loop through those, right? Because how can we act? What if one has 5 things in it? What if one has 1 thing in it, right? We have to be prepared. And for in loops is how we can do this programmatically, no matter how many things are in there. So we can just do for let's item in items. Is this confusing if I do item in items? I will do single item instead. Okay? So, now we will say, I'll pull this out to make it, no. I will keep this item, and then I will say let single item equal items at item. So now, what is single item going to be? Exactly. Single item will now be equal to this. Because items is this, right? And if we do a for in loop through this object, the let item in items, the item will be hard treat shell, soft treat shell. So if we do items at hard treat shell, we get the single item, which is cost and quantity, okay? Is anyone confused by that? Besides my name? I'm sorry. But it's like, what else am I supposed to do? What am I supposed to do? Come on. So now we will say total plus equal single item dot cost times single item dot quantity. And then out here, we can return the total. So if we console.log tacocat.get .current inventory, we get 1710. Is anyone confused on how I did that? This part of the problem actually isn't too bad. You just have to know how to navigate deeper and deeper inside this nested object. There are 3 levels to that, okay? And we use the for in loop because there we can capture every key inside of a variable we define. Right? In the item. In the category. Is anyone confused by this? It's cool. Don't worry. This is a little confusing. Yeah.
Sorry, I'm still not clear how the item is different from the single item. Is it because the item is acting as the key, basically, and the single item is the value now? And once you get to the let?
Yes. Yeah. Yes. That is correct. Items is the overall object because we were saying let something in items. So the focus of this for in loop will be that object items, okay? The key will be item, and the value will be single item. Because single item is set equivalent to, single item is assigned to items at item, which will give us the value in that point of time. So now we have item, which is the key, and single items, which is the value. Yes?
So when you say if the category key is not in cache, there's no key in cache.
So what we are
Cache is empty.
So what we are saying here, for let category in this, what is this?
Object.
It's Taco Cat Inc., right? The main object. So category in each iteration of the for in loop will be a string. It's literally going to be a string, and it's going to represent each literal key in the object. So each time it will be gourmet shell, then gourmet fish filling, then gourmet veggie, then gourmet seasoning, then cache. We don't want this to be equal to cache. If it is cache, we do nothing. So that's why I say, if the category is not cache, then we know that it's one of these other objects of nested objects. So we can do this logic of going inside of them. Because what would happen if we tried to do a for in loop of items, where items was 0, right? Like category is an actual string, so we can just check to see its value and see if it's cache. Because cache is not like the rest. We don't want to interfere with that one, right? Any questions? Okay. What is the next thing? The sale. Okay. So they say that they give you like a... Okay. So they're going to say they want a sale function now that takes an order. And an order will be an object of each thing, right? And then they want to say how much it is, and how much cash you will have, and how much quantity. It wants to do the whole shebang, okay? Subtract from the quantity, make the cash larger. Sorry. Make the cash go up, and then yeah, and say how much it is, I guess. Yes, give the final price at the end. Okay. So, I will go up here. So here I will say Taco Cat Inc. dot sale is going to be equal to a function, and here it will take an order. The order will be an object. They give you this in the README. They give you what it will look like. Okay. I will copy and paste what it looks like over here. This is what an order is going to look like, okay? So, the first thing we will do is make a final price variable. Because we know that's the thing we have to return, right? That's what sale returns. Sale does other things, right? But the main goal of sale is to give you the final price. Well, not the main goal. They're all the main goals. You have to do all of it or it's wrong, okay? But what this function needs to return to you, return to the user, is the final price of the sale, okay? So this is a good variable to have right off the bat. So now I will say for let's category, let category and order. Why am I doing this? Because what I think we should do, I think that we should loop through this. Here we have everything we need, right? we have the category, and we have what they want, right? So then we have how much that cost, and we could just subtract 1 from the quantity. And then we can add the cost to the cash. And it's that simple. We have everything in the order, okay? If you don't understand what I just said, bear with me. So let current order item equal to order at category. Okay? So order at category will be, oh, I don't know, I was pointing at that screen. So order at category will first be hard treat shell, and then it will be salmon, right? Order at category, gourmet shell, will be that, okay? So now, still inside the for in loop, now that we have that, we can do this. We can do final price plus equals this. I can also write Taco Cat Inc., but I'm just going to write this because that's literally what it is, right? Right? Okay. So this at the category, because we know the category is one of these, right? And we know that is the outermost object in this thing. And we know we don't have to check for cash because the person who's ordering something will not be ordering cash, okay? I mean, maybe we should, because then they could be ripping us off. But we won't. This is not right. This at category at current order item dot cost. Who is confused why this will get us to this? Who doesn't understand? Why? I know, I'm just joking. So basically, we're looping through order, right? And we know that these things will be inside Taco Cat Inc., right? Because they're ordering from Taco Cat Inc. So it's like we don't have to make sure if they're in there or not. But what we want, do you agree, ultimately what we want to add to the final price in each order thing will be the cost, right? So if I say final price is now going to be equal to this, what is this? What is category? Category in order. So the category in the first iteration, let's say, is gourmet shell. So Taco Cat at gourmet shell. So that means that Taco Cat, we're now looking at this object, right? So now I say at category, we go deeper, another bracket, another set of brackets, current order item. What the hell is current order item? It's right here. Order at category. Order at category, it was gourmet shell, right? Is this hard treat shell. So hard treat shell at hard treat shell will give us this object. And we know now that this object has a cost property. And that property is a number, and we can just add it to the final price.
So, if I would have done this, I would have done this and not include category and do current order item. Because to me, current order item equals order category already. Like, does that make sense? Like,
Order at category is a value, right? It's going to be one of the values of a key value pair in order. So that will be hard treat shell. So you're saying you would have done this at current ordered item, right?
yeah.
This is Taco Cat, right? So this at hard treat shell undefined. It doesn't exist. Hard treat shell exists deeper inside one of these things. inside gourmet shells. So you actually need the category too, because we're looking at the bigger object, right? And we have to start diving in from the surface. You can't just start down below, right? Does that make a little more sense? Cool. Is anyone else confused? Sick. All right. So now we added that thing to the final price. And this is all happening in a loop. So this will happen every time, right? So now they gave us some money, right? So now we got some cash. So we can do this dot cash is going to be plus equal to this at category at current order item dot cost. We're going to do the same thing we just did with final price, except put it into our cash. Because yeah, this is going to be part of your final price, but it is also going to be part of my pocket money, okay? Does that make sense? Yeah.
You also, outside of that, you just add this dot cash plus equals final price.
Yes, you can. It will be the same thing. I like that better. I'll do that. Well, I won't delete it. I'll comment it out. So, but we have one more thing to do. If you just bought something from me, the quantity goes down by 1, right? So we do this at category at, what did I say? Current order item dot quantity. Shit. Minus. I'm accessing the quantity the same way I'm accessing the cost. We already know where exactly we need to be because we're looking at the order and the category in that order. So we can go into the cost and quantity object. And we just do minus, which is the same thing as plus, except subtraction. So now, out here, instead of doing this long thing, we could just do this dot cash equals, plus equals total final price. Because if we're adding to cash the whole time, instead of just adding to the, if we're adding to the final price the whole time, instead of adding to cash the whole time too, we could just do that all at once at the end. That makes more sense to you. Otherwise, you could do it here. Whatever. Then we return final price, and that's it. Any questions? The trick for this problem was to figure out how to get to the cost and quantity. How do you guys feel about objects now? They're not so bad, right? Arrays are all in order, but objects are actually very easy to manipulate as well. You can add things whenever you want, and delete things whenever you want, it doesn't matter. Change them, whatever. You don't have to know the index, you just have to know the key. Is everyone feeling okay? You guys sure? Alright. I guess we'll do a little bit of today's lecture, and then I'll go into the the slides. The slides. So. It bothers me that there's an E here in reference. Anyway. What should I tell you guys? Okay. Someone name some primitive values. We got a string. Boolean. Number. What else? Undefined. One more that you need to worry about. Null. Right? Okay. So, these things behave the same way when you assign variables their values. A copy of that value, well, how's the best way to describe it? So, here, if I said let my string equal to hello there, and I said let your string equal to my string, and I said console.log my string, and I say console.log your string, what happens? We get two hello there's. What is actually happening here is when I say, okay, let my string, this variable my string, I'm declaring it, is now going to be assigned the value of this string hello there. On the next line, I'm saying a variable your string, I'm now declaring, and I'm setting it equal to another variable? No, that's not how it works. For primitive values, what happens is that this thing, it actually takes a copy of whatever this is. It copies the value here and puts it in here. So if I did, before I console log anything, if I did my string, my string plus equals yo, 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 you see that your string was not affected. It's just hello there. Because when your string was assigned, it copied what my string was in that point of time. It just copied what the value was, pasted it into your string, and your string is no longer touched. My string was altered. Well, it wasn't actually altered. The value of my string was reassigned, okay? Because primitive values cannot be mutated. They can only be copied over. It is no longer the value hello there. It is now this value. Hello there, yo, 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 yo. This isn't really new, but I'm explaining it in a sort of a different way. Does this make sense? You guys can see how these things, my string and your string, aren't actually the same thing. If I didn't do this, and I said console.log my string is equal to your string, we get true. But I just said they're not really the same thing. That's because when we are comparing these things, we look at the value. What the value is actually equal to, okay? And hello there, you're not altering it anymore. Hello there is actually equal to its string hello there. Strictly equals. Any questions? Cool. So, let's talk about complex values. What are some complex values? Arrays and objects. Cool. So, let's focus on arrays because arrays are kind of just, I don't know. Let my array, I'm going to set that equal to 1, 2, 3. And I'm going to say, let your array, I'm going to set that equal to 1, 2, 3. Okay? So if I console.log my array, and I console dot log your array, I get. Oh wait, let me get rid of this. I got 2 arrays over here, 1, 2, 3. However, these things are not equal to each other. They are 2 different arrays. They are pointing at 2 different places in memory. And that's the thing about complex values. There's a thing called reference. What we are looking at when we are using the strictly equals operator is not the values inside of these 2 arrays, but what places they are in your computer's memory. Okay? And they are in 2 different places. But now things get tricky when I do this. Now, your array and my array are the same thing. After I declare your array, if I do my array dot unshift, yo, 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 oh, shit. I got a little too excited, sorry. Both things have been changed. Both. Because when you assign something to a complex type, a copy of the value is not being made, okay? What is actually being assigned is a reference to that object, to that array in memory. A copy of the reference is being put into your array. You can think of this, what's a good analogy for this? You can think of this as this array is a house. What my array, you're going to want to take this variable and throw it around your functions, right? What my array actually is not the house, but it is an address to your house, right? And if I wanted to assign your variable, my house, I can't just throw my house at you, but I give you a copy of my address. It's kind of like that. But the house is somewhere else, but they're both pointing to the same location, my copy and your copy. Okay? That's why this is a thing. And unshift complex values can be mutated, right? So that means that when you do unshift yo, 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 I am putting this string in the front of my array. But since your array is my array, they're pointing at the same thing, so whatever your is still going to be altered as well. But now, when you console.log down here, triple equals, it's true. Any questions? Yeah.
Is this working that so copying an object doesn't get bogged down in
The reason why it's like this?
Yeah.
I have absolutely that's a good thing to research that. I think that's like a pretty good guess though. However, I do want you guys to be aware of something called shallow copies, okay? And when I say shallow copies, I'm referring to slice, okay? Imagine my array is now 1, 2, and then another array. Everyone agrees this has 3 elements in it, right? My array is an array with 3 elements. But the third element has 3 elements of its own, because it is also an array. Does that make sense? This is just a nested array. So what if I said your array is equal to my array dot slice? That is a good way to make a copy of the array. Because now, they are not the same anymore. This is not affected by this. They're pointing to different things. What slice does, you wrote your own slice functions before, it declares a new array and returns it for you, okay? So slice, dot slice, passing nothing into it, gives us a shallow copy. So you might be asking, what does shallow actually mean? Well, what if I didn't do myArray.unshift yo 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 yo? What if I did myArray at 2? Both of them got affected. This is why slice could actually bite you in the butt, alright? It makes a shallow copy, meaning that it copies everything at the first level. This, when it hits this, when slice hits this inner array, it does not copy its value, it copies its reference, okay? And then its reference is put into your array. So when I say my array at 2, at index 2, 0, 1, 2, and I unshift this thing, both of them are affected. And if I put this back in and I say my array at 2 is triple equal to your array at 2, you get true. Whenever I say shallow copy and you read shallow copy, this is what that means, okay? It means it doesn't actually erase, it doesn't actually change the, it doesn't actually go deeper into the nested arrays or the nested objects and copy the values inside of them. What it actually does is it just copies the reference. Because that is quicker. Yeah.
The only time it would be called a shallow copy is if there's a complex data type within the array.
Well, you should always refer to slices producing a shallow. Because you will never know if there is an array in there or not.
Okay. Or there might be one added to it.
Because the other thing, when you're referring to complex values, there are only shallow copies and deep copies. Okay? Shallow copy does this. Deep copies goes down and down and down and down and down and down until you just get rid of the values.
Is that the scope of this lecture to find out what a deep copy is?
No. Any questions on that? That's kind of all I wanted to show you before I go into the slides, which will probably explain things much better than me. Can I go into the slides? Do I have your permission? Okay. Whoa. Is anyone still confused? That's fine.
Just a quick question. If you were to use the word new when you're using the slice, would that make a deep copy?
What do you mean using the word new? Like the keyword?
Yeah.
Like new slice? What do you mean?
Like an object equals new, whatever you're trying to copy.
The new keyword is like saying like let this variable equal like new object would be a new instance of that object and they wouldn't be the same.
Okay. So
When you say new, like if you make an object with a bunch of methods on it, you know, and then you make another variable and you say new the name of that object and invoke it, what you get is that object with all of its methods, but they won't be the same. It would be an instance. Don't think about the new thing with anything here though. But don't think about the new keyword with this. So pointers and memory. So we'll talk about primitive and complex, variable assignment, passing values into functions. Didn't show you that. And equality operators and arrays and dot slice. So you guys did a great job naming all of the important ones. We're not talking about symbols because it's not covered in this course. But the primitive values in JavaScript are string, number, boolean, undefined, and null. Okay? And the complex values in JavaScript are objects and functions. I didn't say functions because we're not really talking about that right now. Objects include arrays because arrays are actually objects. Okay? Remember, type of array is object. Type of null is object too. Let's not talk about that. So, primitive, complex, observed behavior. Strings are primitive values. So if I say let British city equal to York, and American city equal to British city, and American city equals new plus American city, and we console.log British city, we still get York. Even though we said American city is now going to be equal to new plus, even though we originally said American city was equal to British city, right? This is what I showed you before, except there's an extra step here, okay? What it's actually doing is copying the value at British city, which is a string York, and assigning it to American city. So when we do new space plus the string York, which is what American city was here, British city is not affected. British city is still just York, okay? Any questions? So arrays are complex values. So if I did let British city equal to York, and American city equal British city, and American city dot unshift new, and you do all that stuff, British city is new York, has two values in it. But that's not right, right? That's not what we intended to do. That's because both of these are pointing to the same York array. And when I unshift new into American city, British city is still pointing to that thing that just got unshifted on. So now, if you console out both of them, you get new and York. Okay? Why do primitive values and complex values behave differently? You'll be able to answer that question at the end of this lesson. So, when we assign primitive values, when you assign a primitive value to a variable, the variable stores a copy of that value. So let first equal 20, first stores the value 20. So you see here, can everyone see this? Can you guys see this? All right, cool. So the variable first stores the value 20. So let second, well, first is equal to 30. Now first stores the value 30. Then second stores its own copy of the value 30, okay? The value is copied and stored inside the variable. Does that make sense? That happens with every primitive value, okay? Strings, undefined, null, all of them, okay? Second, plus plus, second now stores a new value of 31. Okay? And when you console log first and console log second, you get 30 and 31, right? First is 20, then we assign it to a copy of 30, then we declare second, assign it to a copy of 30, then we say second plus plus, so second is now equal to 31, we got 30, 31. This is simple, right? Everyone understands this? But now, isn't this the same thing? Right. So second plus plus has no effect of the value stored in first. Saw that on the last slide. So complex values, when you assign a complex value to a variable, the variable does not store a copy of that value, okay? I said this before. Not a copy of the value, but it stores a reference to that value in memory. The value is stored somewhere in memory, and the variable stores a copy of that reference, okay? The reference points to the value. So we say let first equal 1020. First stores a reference to 1020. So first, the variable is pointing to the reference. And this 0x001 number down here, can you guys see this? Can you guys see it now? So the variable first is pointing to this reference, 0x001. Usually when you see a 0x0 thing, that's usually an address to some point in a computer's memory. So don't be like weirded out by this number. Just think of this as the address, okay? First is actually pointing to that address. The address is pointing to the value, okay? So if I do first.push, first still stores the same reference. It's still storing this, but .push pushes it into this value, okay? So console.log first, you get 10, 20, 30. That's what we say by mutation, okay? The value is changed, but the reference remains the same. Okay? Everyone good so far? Plus, everyone good so far? So, if I say let first equal 1020 and I say let second equal 1020, second stores a new reference to a new array. They are not the same. This is 0x001 address. This is 0x002 address. They're arrays that live in different places. They're two different, like, entities, okay? But they look the same, you know, but they're not. Does everyone understand that? So since first and second reference different arrays, pushing a value into second will not affect the array that's referenced in first. So if I do second.push, second is pointing to something that lives at 002, right? Not at 001. So first is pointing to something that lives at 001. So the array that lives there will not be affected. Only the one at second will. Does that make sense? Is anyone confused? Okay. So, if you console log first and console log second, you will see that first is not affected and that second has the 30 in it. And besides all this nonsense over here, it's not nonsense, it's very true, but that makes sense, right? If I say let first equal this, let second equal that, if I push something into second, why should first be affected, right? This makes complete sense. If this is like overloading you a little bit, just look at that. This makes sense, right? In no way should that ever affect anything else. Right? Okay. So, but here's where things get weird, okay? If I say second is now equal to first, second now stores a copy of the reference that was originally stored in first. Because when you assign something to a complex data type, what is stored inside the variable is a reference, okay? A reference to that value in memory. So, naturally, when you assign another variable to another one, what is copied over is that reference. So now, if you see this diagram over here, variable first and variable second are pointing at 0x001, 0x001. They're pointing to the same place. Does this visually make it more clear for you? I think this diagram helps, even though it's very basic, right? So if I say second.push, it's pushing into this value. But first is also pointing at this value. So doesn't that make sense that first will also be affected? Doesn't that make sense? When you look at things like this, that first and second are pointing at the same reference, and those references are pointing to the same value. So if you mess with one variable that's pointing to the same reference as another one, that one will also get affected. And this is when I first introduced arrays to you, this is what I meant by when I said that mutating arrays and mutating objects can sometimes be dangerous. Because you never know, if you assign things to each other like this, things could be messed up. Okay? You can mess other things up. Especially when you have two things pointing at the same nested object or something like that, and you make shallow copies of that object, and then everything inside is actually still pointing to the same data. Mutating data can be dangerous and is usually frowned upon, okay? In production. But anyway, does anyone have any questions on this? Yeah.
Related to the shallow copy thing, does it work like that because each, like you have the array with an array inside of it? Is that second array that's another reference number?
Yeah. Like the element being stored, there is actually a reference.
That is the same.
Say it again?
And it's not the same as the first one.
What do you mean the first one?
Because
Like an array
like
with an array inside?
if you had an array 10, 20, and then another element that was 30, 40, would the element 30, 40 reference number?
Yes. 100%. That's a good question. Did everyone hear that? In that example I showed you guys, where I did the slice thing with the 1, 2, and then 3, 4, 5 in its own array, those two arrays, right, the outer array and inner array, have different addresses in memory. They have different reference numbers, okay? So that's why when you, even like slice, okay, slice did not make a copy of that inner array, right? Even assignment doesn't make a copy of that inner thing, right? If you assign that thing, what is being copied, well, no, the whole thing, forget it. You guys get it though, right? This makes sense. Okay. So this is why slice is actually cool though, okay? It's not a deep copy, but it is a shallow copy. So let first equal 1020. This is a great way to just make a copy of something, of an array, just like that, right? So second equal first dot slice. Slice actually creates a new array. So now second is actually pointing to somewhere else. Does everyone see the diagram? This makes sense, right? So if I do second dot push, first and second reference are referencing different arrays. So second is the only one that has the 30 in it. First still doesn't. Does this make sense? I could go next. So I don't want me to explain that again. Slice makes a copy of an array. That is important for you guys to remember, okay? So now we were going to talk about passing primitive values, okay? So we have a variable mynum, set it equal to 10. And then we have a function defined here that says adds 20. That takes a num and says num plus equals 20, and then it returns num. So we say let returned value equal adds 20, and we pass it mynum. So if we console.log mynum and we console.log return num, we get 10 and 30, right? Mynum is just 10, right? Adds 20 returns a num, and it is the num that is thrown in here plus equal 20. You assign that num a different value and return it with 20 added to it, right? Does this make sense? This is a very simple function that just adds 20 to whatever you throw into it. And you see how my num has not changed. What are we passing into a function, though, if we pass in a complex value? You guessed it, we are passing in the reference, okay? My array is an array of just 10. Function pushes 20, takes an array, and it says that array dot push 20, and it returns the array. But returned array is now going to be equal to pushes 20 invoked with my array. So if we console.log my array and we console.log returned array, both things have now 20 pushed into them. Because the thing we threw into the function was the reference to that array in memory. So the reference to that array was push 20. So that means my array is altered. Okay? I feel like you guys never would have ran into this problem before, because usually when you needed to make new arrays in the beginning of your functions, you would say let results array equal empty array. This would solve this problem immediately. Right? Another way around this would be to say array, you could say let results array equal array.slice, right? And then it would be different. But this is important to realize. This array that you throw into here, the reference is being thrown in, so if you do mutate it, what was happening outside is going to be changed. Okay? Does that make sense? Same thing with assignment. If you pass a complex value into a function, the reference is being passed, not the actual value. Are you guys sure about that? Okay. So, equality operator and value and reference. So, triple equals will compare complex values by reference and not by value. So you have array 1, 1, 2, 3, array 2, 1, 2, 3. Console.log array 1 is equal to array 2. You get false. They look the same, but they're not, because they're pointing to two different places in memory. So if you ever tried this before, empty array, triple equals empty array, is false, because those are two different things. They live different places, they're different people, right? They're different arrays or objects. Everything I'm saying about arrays is the same thing with objects, okay? Any questions on this? Triple equals compares the reference. Okay? So, since now we are saying array 2 is equal to array 1, which is equal to this array, what is array 2 actually being set equal to? Yes, a reference to array 1. So, if array 1 triple equals array 2, you get true, because they share the same reference. It is the same reference. Okay? Any questions? Cool. So an array is in dot slice. So we showed earlier that dot slice creates a copy of an array, yada, yada, yada. Boom, they're not the same because this is a copy. Well, wait, there's an array here. Doesn't matter. Array 1 is the reference of this outer array, not the inner array. So that reference is copied. Well, no, I mean, it's not copied. That reference is no longer being pointed to array 2. This is a new reference. However, this is a shallow copy, okay? If an array has a complex value as an element, only the reference to that complex value is copied into the new array. That's why we say slice makes a shallow copy of an array, and it doesn't make new copies of any complex values stored inside the array. This is true if that array had more arrays and that array had more arrays in it, whatever. None of those things, all of those things would be the same. They would have the same reference value, okay? But it doesn't even matter, because slice doesn't even look that deep, right? It'll just see one element of an array and that thing could have 200 nested arrays, right? Doesn't matter. It doesn't look at those 200 nested arrays. It just looks at the outer array and copies the reference and puts it in something else. And that thing will point to those 200 things, but Slice doesn't have to worry about that. Does that make sense? Yeah.
On the previous version of example of slice on page 11, it seems like you were making a shallow. You said like second equal first dot slice, but then first wasn't modified when you console log first, even though you modified second. So I'm just trying to figure out.
This?
Yeah.
Was it this one?
No, it's the one that set the middle. It says second push 30. Assignment complex values there. Yeah.
Was it this exact
Yes.
one, or is it the next one?
I think it's this. It's not that exact one. No,
This one.
yes. So I guess I was just wondering why second push 30 gets modified first when you console log first. It's making a shallow copy. Oh, that's where my. Yeah.
Were you looking at different
I'm looking at a different page.
Well, yeah, this makes sense because first is 1020, the second is first dot slice. So this is a clock, the shallow. It means second first dot so it says second. Here, this is different. This is saying let second equal first. Assignment and slice do different things. Assignment is just saying, okay, second is now going to have the reference that first has. First doesn't actually have this value. First also has a reference. Does that make sense? Slice, though, slice is different. Slice goes in and copies all the values and puts them in a new array. But if something in that array is complex, like an array or an object, then it will copy the reference.
In this example, there isn't anything inside the array. It's a complex array. The example
In that one, yes, yes. There is nothing different. But, where was it? Does that make sense? Cool. So this is what I showed you before, right? So array 1 is now equal to an array with two things in it. The number 1 and another array, okay? And that array has 2 and 3 in it, okay? So now array 2 is going to be equal to array 1.slice. Cool, we made a copy of array 1 and they're not related anymore. But if we do array 1 at index 1, which is this array, and we push in 4, and then we say console.log array 2 at 1, we get 2, 3, 4, and you see that array 1 is triple equals to array 2. At array 1 at index 1 is triple equals to array 2 at index 1. Because slice is shallow. Only the reference to the complex value is copied into the new array. Okay? Does that make sense? Cool. So a recap. We talked about primitive versus complex. We talked about variable assignment. We talked about passing values into function, quality operators, and values and references. And we talked about arrays and slice. Any other questions before you guys take a break for 5 minutes? And I will slack out pairs at 8 o'clock. Cool. Go take a break. Good job, guys. Nice. This week only gets harder and harder. Isn't that fun?